Good afternoon and welcome to this special STAAD Special Interest Group meeting on October 20th, 2016. Today we're going to be talking about using parametric models in STAAD Pro. Now let's go ahead and introduce what the topic of parametric models are. In STAAD Pro you do have several different options for generating a finite element mesh. We have a couple of traditional finite element mesh tools such as your Generate Surface Meshing tool or your Modeling Plates tools. Those of course are perfectly acceptable to use, but what I want to show you today is some of the advantages of using a parametric model in order to generate a finite element mesh instead of those traditional options. Now this method does offer some advantages over some of the other methods that you'd see in STAAD Pro. First, it enables you to preview the final mesh state of the wall, slab, or panel before deploying the mesh entirely into the remainder of the model. Several trials or prototypes can be visually examined before committing the most suitable one to the input file. This greatly minimizes the inconvenience of ending up with an undesirable meshed panel. Also, during the process of meshing, the program will automatically take into consideration existing nodes that lie within the boundary of the panel, which is actually a huge advantage. You simply will just have to define your panel boundary, and then the remainder of the nodes will automatically be considered as control points, which is to say that the elements will be created in such a manner that some of those elements will have these nodes as they're in their incidence list. Control points may be panel points of a truss which supports a multi-span slab, or a foundation slab that supports several columns. In addition to that, it also allows for the definition of lines on surfaces along which nodes should be created. Thus, for a continuous slab over a wall, for example, a line only needs to be drawn to define the intersection. Nodes will then be created along that line, and they will automatically become control points for the wall when it is meshed later. The problem of correctly modeling the monolithic connection between the two panels is now easier to handle as a result of this feature. And I'm going to show you all of those advantages kind of one by one. I'll point them out as we go through the model. Now before we do that, I did want to take a chance to kind of show you some of the traditional methods, just in case anybody in here is maybe a newer user of STAAD Pro, or maybe not as comfortable with some of the other options to generate a finite element mesh in STAAD Pro. So what we're going to do is we're going to start with just a sample STAAD Pro model, and I'm going to go to my Geometry tab, and of course I'm also going to select my Plate sub-tab. Now up in my Geometry toolbar, I do have a couple of traditional tools which I can use to create a finite element mesh or plate elements. I can go ahead and use my Add 4-noded or Add 3-noded plate tool. With that tool, I'd have to draw one panel at a time and then eventually break that up into a smaller finite element mesh. And then I also have our Generate Surface Meshing command, which is one of the ones I'm going to discuss here or show you how to use in a moment. With the Generate Surface Meshing command, what you can do is you can create a total overall area. You're not restricted to just 3 or 4 nodes. It's also a lot easier to maybe add things like holes within your slab system, for example. So what I'm going to do is I'm going to go ahead and show you how to use this tool, and then I'm going to show you how to use the Parametric Models tool and some of the key features that might be a little different. Now within this particular model, I've also added a few extra nodes. So you're going to see some beams and columns. I have a node here which actually represents a point load on my slab. So you can see I've added a load right there. I also have these extra 4 nodes which will eventually represent a hole within my slab. You're going to see that with a parametric model, it'll be a lot easier to define a hole in the slab. And for me, I like to just create the nodes and then I can just add everything graphically, which is kind of nice. So I'm going to go ahead and click my Generate Surface Meshing command, and I'm going to say that there's a slab over this entire area. So I'm just going to click around my perimeter at the top of my columns. After I click the last node, I can just right click, which will bring me right back to defining my mesh generation. Now, before this class, I took the liberty of figuring out how many divisions I'd want along each end, and I just kind of copied and pasted them for the sake of time into an Excel spreadsheet. So what you're looking for whenever generating a finite element mesh is ideally you'd like quadrilateral elements. Triangular elements are also acceptable, but what you're most looking for is a uniform finite element mesh to give you the best results. So that would be as close as you can get to an equilateral triangle or a perfect square, the better. So I want to make sure I divide each of these lines up with the equal number of divisions is going to be along each line, as close as I can get it to have a good finite element mesh. Now, doing the traditional generate surface meshing command, you're going to have to kind of know how long each wall is in order to be able to correctly define this division column. You can also define holes within this slab. So after entering this information, we're going to go to the holes area. And you can create a new hole, but one of the things that you're going to notice is that you're going to have to kind of know where you are in space. You can't add a hole within the slab graphically. You'd kind of have to know the coordinates of where you were. And so for this exercise, since I don't actually have the coordinates written down, we'll go ahead and skip adding holes for now. Once we're done, we'll go ahead and click OK, and we can see our finite element mesh. Now it looks like along the walls I probably have done pretty good about maintaining a certain aspect ratio for my finite elements. I can see in through here some of the elements are probably maybe larger than I'd like. Also, one of the things that you're going to notice is that the internal beams and columns were not necessarily used as control points for generating this surface mesh, which basically means that I do not have connection between this slab and say this beam right here. And I'm going to assume that this beam is supporting this slab. So this beam, there's no connection between the slab elements and that beam. So that's an issue that I'm going to, think about. I'm also noticing that, say, at this column location, it's also not connected to any slab point as well. If I wanted to perform a finite element mesh of this particular area, what I really need to do if I want to use the surface meshing tool is I want to mesh each square of these on their own if I need to provide connection between that slab and their supporting elements. Lastly, in addition to that, you're also going to notice that my point load that is occurring right on this node that I manually put in here, that also is not considered as a control point for specifying your finite element mesh. Right now I kind of have that node sitting out in the middle of nowhere, and I need to make sure that that load is being resolved, and right now it's not quite being resolved. So we did pretty good, and you can definitely take care of this particular structure using the generate surface meshing command. But what we'd have to do is we'd have to mesh each region on its own. So what that would look like is kind of taking each one of these areas and generating their mesh. Let's say, for example, oh no. So here I can see I can do each area, and then I may need to massage some things around, things like openings or extra point loads that I want to be considered. Only when you do it in a particular region like this will, if I take a zoom in, will it segment your beams that are supporting it. That's what you're looking for. You're looking for these beams that are supporting the slab to be segmented and to share nodes with the slab so we have proper connectivity. So let's take a different approach now. Let's take a look at parametric models. And what I have here is I have the same exact model that I created. Just to save some time, we're just opening a new version of it. So I'm in the same model I was before, except instead of the geometry tab and the plate subtab, I'm going to go down here and find parametric models. So here I am, geometry and parametric models. And what I'm going to do is I'm going to first start by creating a new finite element mesh. So we're going to go down here and click on our Add button. We'll just call it Meshed Surface 1. I like to, I'll call it a slab. Now this checkbox is very significant. This is one of your major advantages. So we're asked, do we want to use nodes and beams that occur on or inside the boundary as additional density points and grid lines? We're going to go ahead and say yes. What that means is that every node and line within the perimeter of the slab that we create will be considered control points or density points within the slab, meaning the slab will be officially attached to them. If we have monolithic action and we have force transfer between the slabs and the beams and the columns, that will be critical. So we're going to make sure this checkbox is selected, and we're going to go ahead and click OK. Now what we're going to notice is that our mouse is going to change. So I'll go ahead and click along my perimeter, basically the same exact way, in the same exact order that I had to do for my generate surface meshing command. I click my last node, and then I'm going to right click to close the polygon. Now I have a couple of different options here. Now perhaps you noticed that when we were generating our surface mesh using our surface mesh command, since I had an irregular polygon that I created, I was not allowed to have quadrilateral meshing. I was only allowed to have triangular meshing. STAAD Pro will automatically take a look at the polygon that you model using your generate surface meshing command, and unless you are a quadrilateral, the quadrilateral meshing won't be allowed unless you, like I showed in the second half of that, I generated surface meshing for one of the squares. For that case, I was allowed to have quadrilateral meshing, but otherwise I'm only allowed to have triangular meshing. Now I can see, once I go in here, that I am allowed to have quadrilateral meshing available. I have a couple of different options here, and here I'm in the standard. I can go to a basic, and with the basic I can have triangular meshing. So in case you were wondering, well, where's my triangular option? So we have standard and basic. Now, it's my recollection that one of these options down here might require the Advanced Analysis Engine Plus license. You don't need that license in order to generate a surface mesh using parametric models. I think one of these options would be unavailable to you, though, if you did not have your Advanced Analysis Plus license. So just keep that in mind. So what we're going to do is we're going to divide our boundary segments to optimize mesh quality. We can enter a target element size. Say I want 36 inches as my target element size. Now what you're going to notice is that I don't have to know how long each side of that polygon was. I just have to tell the program what size approximately I want my finite elements to be using this option. So we'll go ahead and click OK. Now we're asked, do I want to add openings? Now this is another advantage. If I go ahead and click yes, I'm going to do a polygonal opening. Click OK. Now I'm allowed to create a grid to show where my polygonal opening will be. For me, what I did is I created some nodes, which is kind of a helpful tip in order to generate that area. So in my snap node panel, I'm going to say snap to existing nodes 2, and then I can create an opening. So it's pretty easy. If you didn't create these nodes beforehand, you could modify the default grid or create your own grid to kind of correspond with the opening locations. So now that we're done, we'll go ahead and if I needed any more openings, I could model them, but I'm done. So I'll click close. So now here I've generated my finite element mesh. It's actually looking pretty good. What I'm noticing is that all of these nodes along here, even the interior nodes, were considered density points within the slab. So now I know the slab is officially attached to these support beams and also these columns. I'm going to notice that my hole or my penetration within my slab is exactly where I wanted it to be. If I zoom in over here, I'm going to notice that even the node that I created in the middle of this floor system where I have a point load coming in was taken into consideration as a density point. So these are all kind of like some of the benefits of doing this. One of the other things that you're going to notice is that this is still called a preview model. These finite elements have not officially been created to the STAAD Pro input file. That is because I can use this approach in order to preview a couple of different options for myself before committing it to the file. So say I wanted to do the same thing again. Maybe I want to do a different finite element size. I can go ahead and do that. I add preview models. Let's go ahead and add another one. So mesh surface 2. And I can create as many as I want, and then I can choose which one I really want to send over to the model. So say I want to do this one. I'm going to set everything the same, except for maybe I'll do 60 inch for my element size instead. So you can see here I have a much larger mesh, and I'm still able to model a hole. So now I have two different options. I've got my mesh surface 1, that was a kind of a finer mesh. Come down here. There it is, mesh surface 2. So neither of these exist in the model, but I have the option to preview them first. Let's go ahead and play around with meshed surface number 1. Now, in addition to being able to very easily model holes graphically, to be able to consider internal points as density points, you can also create additional density points. So let's say, for example, maybe I have a concrete wall, and I'm just going to use these two nodes because it'll be easiest to show. Say I have a concrete wall running diagonal from here to here, and I want connectivity between this slab and that wall. Now that wall isn't exactly in the model yet, but what I want to do is I want to connect this slab to that line so that it'll make it easier to model that wall later. Well, I'm going to come down here where it says density lines, and I'm going to go ahead and click the add point. And then again, you can use your grid. I'm just going to use two of the existing nodes because that's kind of easy for me right now. I'm just going to click on that node and then click across there. And now what you're going to notice is immediately the finite element mesh was divided along that line, and now I will have an easy place to go ahead and start modeling a wall underneath that. Again, none of this exists in the STAAD Pro model yet until I officially send it over. In addition to that, so I have density lines, you can also add density points. So basically you can force nodes to be in a certain place. It's definitely a lot easier than if we were already in, these plates were already in the STAAD Pro model, because then it's about moving nodes, locations, which can kind of get a little bit messier, for example. I'm going to go ahead and save. Now at this point, let's assume that this is the mesh that we like. And now we want to officially send this mesh over to our STAAD Pro model. So I'm going to highlight the mesh I want. I want my mesh number 1. And I'll go ahead and say merge mesh. Now this is part of the model. So if I go back to the plate area, you can see all my plates have been created. I can see my opening is there. I can see my node where I have my large point load on it. That's been incorporated into the mesh. I can also see that, say, these interior beams. Before, when this beam was modeled, it was modeled from column to column. In order to ensure proper force transfer and monolithic action between this slab and this beam, it'd be important for the beam to be segmented at the same exact location as the slab, which you can see was done automatically for me. So that covers all of our major advantages about using the parametric models in order to generate a finite element mesh.